Okay, the 2023 maths paper is off the press, so it's paper 1 here, and the choice has kind of gone back to normal. During the C19 era, it was kind of, here's 50 questions, do 1 out of 50, if you feel like it, that kind of thing. The choice was ridiculous. Now it's kind of gone back to normal, really. 5 out of 6, and in part B, 3 out of 4. So it's not a ridiculous choice. It's kind of, well, it's kind of the minimum choice, really, I suppose. Okay, so first one, 2 values for this absolute equals 11. So an easy one to crack off on. So question 1, pretty straightforward one to start on, which is good because they shouldn't really be killing you from the offset. So let's have a look at that. So the modulus means, basically if you get rid of the modulus, that 5 plus 3m is equal to 2 things. It's either equal to plus 11 or minus 11. So let's take them each individually, and you get 5 plus 3m, let's say, is equal to plus 11 on that side. So you get 3m equals 6, and m is 2. That's fairly fine. The other option is that this was a negative number, so 3m is equal to minus 11. So 3m is equal to minus 16, so it's slightly messier. So m is equal to minus 16 over 3, which is a little bit messy, but it's a valid result nonetheless. So 2 values, m element of r, just to be absolute, you want to be absolutely watertight about the marks. Are they real numbers? They are, absolutely. So they're the 2 numbers. Great. So find the real numbers h, j, and k, and for the real numbers. So the real numbers express k in terms of this. Great. So really all this is just jigging them around and cross multiplying, but that's fair enough because some students still have a problem with that. So it's good to start off in this, so you want to express it in terms of k. So let's get, basically you want to get k on one side and get everything else, shove it over the other. Okay, so, but first step is cross multiply. So j plus k is equal to h, k. Get it over here. So you get k minus hk is equal to minus j. So k into 1 minus h is equal to minus j. K is equal to j over h minus 1. Okay, so that should be okay. So is that k in terms of h and j? Just to check, it is. So k is expressed purely in terms of j and h. Glad. Lovely. Important to check these things at the end. Is just okay. Question 1c. This, they're telling you this is a factor of that quadratic or no, cubic. They're all real. P is negative. Okay, that's going to be handy later. Find the value of p and the value of r. So I suppose if it is a factor, then we can divide that in there evenly into that. So let's do that. We know it's going to work, so let's just plug that in. Okay, so you need a cube there, so we need x multiplying by all of that. So that's x cubed minus p x squared plus x. All right, subtract those. These guys cancel. And you get, okay, you just have to watch the x squareds. Okay, so it's plus px squared minus 2x. Oh, this guy, minus 3x. So it's minus 3x minus 3r. Okay, so what do we need to multiply now? What do we need to get it looking like px squared? Well, it's plus p. All right, so that's px squared minus p squared x plus p. That cancels nicely. So you get p squared minus 3x minus 3r minus p. Okay, so for that to be a factor of that fella, there has to be no remainder. Now, there is a remainder here, which would indicate that there's a problem, but that remainder has to be 0. So that's how we use that. So that now has to be 0, which means two things. It means that has to be 0, that has to be 0. So p squared is equal to 3, and also 3r plus p is nothing. P squared equal to 3, which means p is equal to plus or minus the root of 3. They're real and p is negative, so that means p has to be the negative version of that, root 3. 3r then is going to be equal to root 3, which means r is equal to root 3 over 3. Or another way of putting it, r is equal to 1 over root 3. So they're kind of semi-reciprocal kind of thing. They are just check. So always put a check in on your answer. It's important. P and Q, are they real? They are real. Is P negative? It is. So they're the two criteria. So that is question 3. That's that sorted. And that's okay. That's a nice introduction to the whole thing. Okay, question 2. So we have a quadratic. The real, it has a local min at 3 minus 1, find the value b and c. 3 and minus 1. Okay, so a local min. So it's a quadratic, looks like that. So where's 3? Just to sketch it. Minus 1 there. That's 3. So it'll be something like this. Right. Because it's a quadratic. And it'll be upward facing because it's positive. Yes, that's plus 1, we assume. Well, it is. So local min is there, so find the value of that and that. Well, at a local minimum, f dash x is 0. So let's differentiate the lad. Let's see what comes out of them. 2x plus b, and that's, yeah. Okay, and that's equal to 0. So, which means x is equal to minus b over 2, kind of looking like this, x is equal to minus b plus minus square root of b squared over 2a, a little bit looking like that, but anyway, not surprisingly. Okay, so that's that. That would mean that is equal to 3. Okay, we don't need to worry about them being 2 points because it's a quadratic. There is only one local minimum. In a cubic, you might have a couple of minima, and you'd have to pick the local. But that is 3. Okay, so b is minus 6. That's all right. What else do we know about c? Okay, so how do we get c? Okay, so how do we get c now? Okay, well, if x is 3, yeah. If x is 3, then what's y? Y is equal to x squared. Chop it into the function. So y is equal to 3. So x squared minus 6x plus c is equal to 3. So yeah, oh yeah, and x is 3. Okay, so x is 3, so that's 9. Minus 18 plus c is 3. So c, that's minus 9, bring it over there and you get 12. Okay, so yeah, find the value of b, value of c. Check them. Are they real? They are. Grand. There's no other really restrictions on them. Away you go there. That's all right. Find the value of the following limit. Okay. Limit as n approaches infinity and beyond. Okay. N over n plus 1 plus n plus 1,000. That 1,000 is going to be vanquished very soon. You think you're looking big and confident. Wait till you see the limit crush you to the bone. Okay, anyway, kind of got distracted. Okay, so what do? We multiply above and below by the n's just to get rid of them. All right, so basically, dividing above and below by a thing, divide that above and below by n, and you get 1 over 1 plus 1 over n. This one, it's the same thing, divided by n. This guy, this 1,000, you think you're big. Okay, over that. And then this guy, oh, what do? 1 over 3n will be fine there. So now, in the limit, anything with n approaching infinity, if it's underneath there, will be, n is massive, so this will be 0, basically. So that's 1 over 1 plus 0. 1 plus 1,000 gone. 1 plus 0. This guy goes to 0. Or, well, the whole number goes to 0, because that's 3 to the power of infinity, which means the massive number, which means the whole thing goes to 0. Okay, so it's equal to 1 over 1 plus 1 over 1 plus 0. So it's 2 equals 2. So all of that is reduced to a mere 2 in the end. And that's okay. We're okay with that. Right, so function. Function g of x. It's defined for minus 2, 2. So it inclusively, so it includes the minus 2 and the plus 2. And the graph is shown below. Yeah, so and it's kind of a fiddly graph. And the reason it's a fiddly one, or they're trying to make it look fiddly, is that they don't want to make it look like a nice even x squared or anything like that, or a cubic or something. They want to make it look fiddly where it's not terribly well behaved. So you have to kind of guess what's going on. Draw the graph of gx minus 2. So basically it's, okay, that's 1, okay, that's 3. My scale isn't the best. Probably doesn't look too heroic, this scale, but I think I'll get away with it. I think I've got away with it. Minus 1, yeah, this squiggly bit there is minus 1. That's 2, and that's 1. Okay, so basically draw the graph of gx minus 2. We're just going to bring it down by 2. We're going to bring it down by 2. So that point there is going to be now minus 1. We'll just put minus 1 here just for the sake of scale. So that's that. It's going to go up to now 2 above that, which is 1. And it'll go that way. Now, okay, so that's what it'll look like. Exactly the same thing, just shifted down. So that's gx minus 2. So very simply, it's just the same thing, except minus 2 taken from everything. So shifted down. Okay, so translation downwards. That's fairly okay. Large a domain as possible. That one's grand. Gx plus 3. This might be slightly trickier. A larger domain as possible. Gx plus 3. So if x is minus 2, then we're putting that in there and you're getting g1. So whatever was at g1 is going to be here. So it's so at minus 2 you're going to have basically everything here is going to be shifted, not down this time but across. So we're shifting by 3. So we're translating that way by 3. So anything here is going to be here. So that's where we go. And it's going to end up at the same vertical position, so 3. And so it'll be 2, if not, so it'll be there. Okay. Yeah. So my graph doesn't look great, but that's basically it. It's going to be that. All of that section there is now going to become that. Okay, so the graph is going to be basically that. And that is 3. That's a -2. Yeah, so that's a little bit trickier because they're shifting to the left rather than up and down, uppity downity, but that's all right. Okay, so question 3, prove that root 2 is not a rational number. So root 2 is nuts. It's crazy. We're going to show it out of the club. It's not a rat. Okay, so it's not a rat. The way we do that is by contradiction. We're going to be controversial. We're going to say it is a rat. We're going to smoke it out. It is a rat first. So if it is a rat, well, the definition of a rat is root 2, so the number then has to be expressed as a over b, where a and b are nice z's, they're integers. So that would have to be the case if root 2 was a rat. Okay, so square both sides, you get a squared over b squared is equal to 2. That means a squared is equal to 2b squared. Now, so as a result of that, what we're saying there is, now, so with that 2, so because these are z's, they're integers, that means a squared has to be even. Must be even. Similarly, if you were to do it the other way, so you would say, so if you let, so because a is even, let a is equal to 2m now. So a is, or sorry, a squared equals 2m, because we know that a is even, so it can be expressed as 2m, where m is z, is an integer. So now what happens? You get 2m over b squared is equal to 2. So b squared is equal to 2m over 2, which is equal to m. So now, that is, so basically you're saying that a squared has to be even, and you're saying, oh sorry, that a squared equals 2 squared, a squared must be even, yeah, okay. So now, because a squared is even, then a is even. Basically a and b are even. So basically what it's saying is, yeah, the one condition with this is, in order to prove that it's rational, is that they mustn't have any common factors. But you've just said there that they do have common factors, that a squared and b squared do have common factors, if you're assuming this. So it assumes that, so basically that proven by contradiction. So it's saying that this is now, we've disproved that. Because a and b have common factors. So in other words, it's disproving that. It's saying the root 2 cannot be expressed as a over b, where these are integers, and they don't have common factors, because we've proven that they do have common factors. So root 2 cannot be a rat. It's a rat. Okay. T is a positive real, and lots of logs. Log 90, log 2070, log 81t equals 10. Now, happily, these are all nicely divisible by, or factors of 3. Find the value of t. So you're looking for t. And give your answer t in the form 3 to the power of r, or something like that. So, a nice hint there, use this formula. So, CB log C A. So it's saying if you want to change the base from A to C, a new number C, so the log will be base C in both of them, so you get the log of B and over the log of A in the new base C. Right, so the first one, I think we want to break them all down to 3. So I'd say the first one will probably be all right. We'll leave him alone. Log 9 of t. Okay, let's have a look at this fella. So our new log is now going to be 3 because we want everything 3. We're going to be irrational about 3. We want 3 everywhere. So it's b, which is log t, over a, which is the 9. Okay, and log the base 3 of 9. What number do you have to raise 3 to get 9? Well, it's 2. Okay, so that's nice and even. So it's basically log 3t over 2. Okay, so what we get is log 3t plus log 3t over 2. This is 27. So really similarly, we're not going to do it out again. That is what? 3 to the power of what gives you 27 is 3. So that'll basically be divided by 3. 81 is 3 to the power of 4, is it? It's 9 squared, yeah. So that's 4, yeah. Nice kind of series-y thing. Right, okay, so add them all up and yeah. Okay, so find the value of t. Okay, so now just mixy up all the logs. So it's log 3t into 1 plus a half plus a third. It's like a bit of a series going on there. Quarter equals 10. Yeah, so let's do a 12 on it. So it's 1 plus 6 over 12 plus 4 over 12 plus 3 over 12 equals 10. It's 10, 13, 13 over 12. God. 13 over 12 plus 12 is 25 over 12 equals 10. So log the base 3t is equal to 120 over 25. Okay, part B. What the hell does log base 6 of m means where m is a positive number? Okay, that's a very existentialist question. So log base 6 of m means what number do you have to raise 6 to get m? So that's the other way of putting it. So it's saying if that number is r, then 6 to the power of r is equal to m. So up there it would be 120 over 25 to the power of r. Equals m. So basically what that means is that number is what number do you have to raise 6 by in order to get m? If m is a real number and m is bigger than 6, well then it's saying that log 6m is bigger than 1, because log of 6 to 6 is basically 1, because you only have to raise 6 to the power of 1 to get 6. So anything higher than that means it's bigger than 1. All right, and that's pretty much that. Okay, question 4. For this question, I squared is equal to -1, just in this question, not anywhere else. Complex number z1 1 plus I is a root of z squared plus 3 minus 2iz plus p is equal to nothing. Find the value of p. P is complex, they're telling you. And they're, yeah, so find the value of p. Okay, so it's a root. So we can't, the coefficients are not real, so we can't use the old fiddly bit where the conjugate stuff. So we have to multiply them in. Okay, so let's do, yeah, what will we do? I suppose we could, yeah, it's a root, so let's just put them in. Okay, so 1, if it's a root, then you pop in z1 and see what happens. So it's 1 plus I squared plus 3 minus I by 1 plus I plus p is nothing. Okay, so that's 1 plus 2i minus 1 plus 3, so minus 2, so it's plus I, and then square these fellas with all the minusing going on, drive you nuts. So that's minus 1 plus 4 plus p is nothing. Okay, nice bit of cancelling. That. Okay, 7 plus 3i plus p is nothing, so p is minus 7 minus 3i. Okay, we're all right. We're all right. Check it. They are real, or not real, but integers. Okay, use the MOV. Use the MOV to find the values of w such that this thing kind of comes up. W squared is equal to minus 1 plus root 3i. Give each. Okay, question 4b. Use de Mosa's theorem to find blah blah blah, and w squared is equal to that. Find w. Okay, grand. So it's the usual de Mos. Where's w squared? Minus 1 root 3. So it's in the second quadrant, so all sine, tan, cos. The reference angle is root 3, okay, let's see, is root 3 imaginary bit, 1 the fiddly bit, so what's that? That's pi over 3 being 60, yeah? Yeah. Okay, so w squared. Okay, so yeah, and what's the modulus? Well, it's 3 plus 1 is 4, square root of that is 2. So it's 2 cos yeah, okay, so it has to be, because out here it's in the second quadrant, so that's pi over 3, the reference angle. So the actual angle is 120, or pi minus pi over 3. So what's left out of pi from that, which is equal to 2 pi over 3. Grand. So cos 2 pi over 3 plus j sine 2 pi over 3. Grand. Now, to give it more general, you have to add in this 2n pi. 2n pi. Now, where does that come from? So, if you have any angle like this, and it's theta, well, or say, let's say, 20 or something like that, then that's the same. That angle is 20, but it's also, if you add on a full entire rotation of 2 pi, then you get the same angle. So really that's 20, or 20 plus 2 pi, 4 pi, any multiple of 2 pi gives you the same angle. So we're adding that in for generality. And we have to add it in because when we get the square root, that generality will yield some results. So That's what it is. So W now is equal to root 2 cos. Now, and using de Mouse's theorem, you just, because he's a little mouse, he creeps in here and the half goes into the angle. So you half the angles, so you get pi over 3 plus n pi plus j sine pi over 3 plus n pi. Alright, so now you just take the instances, n is equal to 0 gives you w is equal to root 2 cos pi over 3 plus j sine pi over 3. So pi over 3, so you just you already have that up here. So w0, let's say, is root 2 half plus j root 3 over 2. Bring that in there, you get this lad. Or you could say root 2 over 2, but it's kind of a little bit cleaner just dividing. Or you could say root 6 over 2, but this is just a little bit cleaner. N equals 1 then. W equals root 2 cos. So with n equals 1, it'll be adding pi to it. So this is our reference angle pi over 3, but now we're adding pi into it, and we get it out here. So that'll be the angle. So all sine, tan, cos, that means sine and cos are negative there. So it'll be root 2. These will just be negative instead. So it's just the negative version of that lad. Right, there we go. So the second one, you're adding pi onto it, which moves it into the quadrant there, the third quadrant where sine and cos are negative, but hence that you get those negatives there. So there you are, the two results. Okay, question 4C. Okay, complex numbers, question 4C, Argand diagram. Sounds very sophisticated, and it is. All very French, Argand, like the mauve. Shows the complex number, this fella. Okay, so where is this complex number? Well, it's up here somewhere. And it's u equals real part A, imaginary part B. So write the complex numbers IU and IU bar in the simplest terms. Okay, so IU is equal to I times A plus B I, which is equal to minus B plus AI. IU bar is the complex conjugate, so you just take that. And the conjugate of that, you only change the imaginary bit. So it's equal to minus B minus AI. So let's take out the minus plus AI. So that's that. And then plot and label the complex numbers on the diagram above as accurately as humanly possible. Okay, so this guy IU, okay, so this guy is there, that's A, that's B. So it would be something like this. So that's IU. And now IU is IU bar then is just the conjugate of that, so it's a reflection here. That's this lad here. So it's that lad there. IU bar. Okay. State a transformation or series of transformation that would send U to IU bar, and don't dare include a translation in your answer. Okay, we won't dare. Okay, so how would we do that? Well, this guy is a rotation of 90 degrees. And that's what happens when you multiply by I. You're basically rotating. So if you imagine that box, it's nice and tall, very narrow, and then it's basically transforms into a very long box with very short. So it's 90 degrees. And then you've got a flippity-boo reflection in the x-axis, or the real axis. So transformation, or series of transformation, I'm going to go for series of transformation. So rotation by 90 degrees, oh sorry, minus 90 degrees, very important. So it's negative, is it? Yeah. No, sorry, it's not negative, it's plus. Yeah, that's positive. That's a positive rotation. Followed by a reflection in the real axis. Is that correct? It is, yeah. Okay, because we are reflecting that and that. So we're keeping the same, yeah, because we're keeping the same real value. Yeah, grand. Okay. Now, okay, question 5. Function to find f of x is 1 over 5x squared plus 7. Find f dash of x, answer in simplest form. Okay. F dash of x. Okay, well, we could say that this is f of x squared plus 7 minus 1. Okay, so chainy rule, so it's minus 1 into fx squared plus 7. That's now to the power of minus 2. And then differentiate what's inside. So you get 10x. So it's equal to minus 10x over 5x squared plus 7 squared. It's in simplest form. I think that is in simplest form. Okay. Function g of x is defined as follows. Find the value of g dash. So this is b. Yeah, g of x. 10 of x over 2 by ln of x. I haven't seen that one before. Find the value of g dash. Oh, that's going to be real chain rule stuff. With pi over 2. ln b. God, that's going to be awkward. G dash of x, okay, is going to be the first by the differential of the second. What the hell is that? Is it 1 over x? Oh, log tables, fucking log tables. I don't have log tables. I'm just going to differentiate log. Logarithmic differentiation. I think it's 1 over x or something, isn't it? Well, that's helpful. Good. Need to know the differential of fucking hell. Differentiate natural log.
Back to something called the chain rule.
Let's go away. That's probably it. Yeah, it's 1 over x. It's 1 over x. Okay, don't have long tables, have to use that instead. Okay, so that's 1 over x. So the first by the differential of the second plus the second by the differential of the first. Ah, fucking tan x, jeez. God. How do you fancy tan over x? Something over sec squared or something. This would be in your long tables, but I don't have long tables because I am a Luddite. Differentiate tan, just tan of x, that's all. Not by first principle, just normally. Okay, so it's equal to sec squared x, which is 1 over cos squared, isn't it? Okay. Okay, tan first by the differential, the second by the second by the differential first. Uh, 1 over cos squared x over 2. Now, if they differentiate the x, it'll be half as well. So, and we're saying we're looking for g dash of pi over 2, is it? Oh yeah, okay, that'll clean things up. Pi over 2 tends to clean things up. G dash of pi over 2 is equal to 2 over pi. 10 pi over 4. 10 pi over 4 is 1, isn't it? 45, yeah, it's 1 root 2, yeah. So it's 1, great. I kind of tie these things up a little bit. So ln of pi over 2 over 2, 1 over cos squared pi over 4, which is pi over 4 cos, yeah. So plus ln pi over 2 over 2. Okay, so cos squared pi over, yeah, okay. Cos of pi over 4 is 1 over root 2, so it's a half, so it's 2. Okay, so it's equal to 2 over pi. Right, so question part C, diagram shows sets F and G, okay. And it's an unusual one, so F is projecting from A to B, and these are just symbols, and then G is bringing it onto these letters here. So find the value of G of F of 3. Well, so you get F of 3 first. So F of 3 is this symbol here, and it's G then, which brings it to W. So the answer there is W. So that's part I of that. And then next bit is the fiddly one. So it's this injective and surjective. So explain why G, B to C is injective but not surjective. Okay, and you're kind of giving a hint there because you're saying it is 1-to-1 but not onto. Okay, so surjective. So it is injective. So it's injective because, okay, so a function has a discrete value for each for each value here in the x domain. So it puts it over to a unique value. Then it is injective, so B from C, G from B to C is injective because it's 1 to 1. Every value of C that is going back has a unique, it's 1 to 1 in a relationship back here. It doesn't have to, injective doesn't have the requirement that every value of B has a corresponding value of A in here. But if there is one, that it's 1 to 1 and it's clear. There's no kind of crossing paths here. Everyone is 1 to 1. So that is injective. Now, but not surjective. So surjective would mean that every value in C would have a value back here. And that's not the case. So Y is the proof of that it's not surjective. Now this stuff is, that question I think people would find quite tricky and just pretty fiddly really, and it's kind of more of an English question than anything else. But it does give you, not surjective, it does give you a kind of a hint there, 1 to 1 but not onto. Okay, so question 6, f and g are two functions. So f of x is x plus 4. So this looks like a fairly straightforward one. G of x is x squared minus 2. Find two values of x. So this is quite nice. That should be fairly straightforward. So f of x is g of x. So all you have to do there is equate them, and you're probably going to get a quadratic out of that. So x squared minus x, bring that over, minus 6 is 0. Looks like it's going to factorize fairly easily. What's that? Minus 3 plus 2. Okay, with that goes minus 3, yeah. So x is equal to 3 or minus 2. Grand. And that's it. No follow-up question. Okay, the next. So find the area of the shaded region diagram, the fiddly bit in the middle. So it's thing you want to watch out for here is just the main thing that'll catch people out is the fact that the area under the curve here for this bit here up to the root is positive, but area under the curve where the curve goes below the x-axis is going to be negative. So if you take the area under the curve, say all the way from here to there, it'll be netting out positive and negative areas. And you could end up with 0 area under a curve if there's a positive and an equal negative. So just be wary of that. You want to take absolute values of the area, really, that's what they're looking for. So this is it, the minus 1 to 2. So just be wary of the areas here. So it's from minus 1 to 2. So you want to get the area under the curve here, which is going to be negative, and that's going to be, so from minus 1 to that intersection, that root, and the root there is x squared minus 2 is 0, so x is root 2. So it's going to be minus 1 to root 2 of that function, area under the curve, which is going to be, so a1 is going to be negative. But really we're only interested in the absolute value of areas here. Then this little section here, this little nib, little bite, that bit is going to be area under the curve 2. So that's from the root 2 to 2 and the integral of that. Grand. So area 3 then is going to be from minus 1 to 2. So from there to there. So that area 3 is going to be the area under the curve. So the area under the curve here, under that line, basically. So it's going to be from minus 1 to 2, the area under the line, and that's going to be all positive. So that's going to be this bit here. So you can work that out by integrating, and you get area 3 is 15. Now, so that is the full area under the curve here. So it's there and there. So it's going to be all of that bit. But you don't want all of that bit. You want the area between the two. So you want that plus A1. So the area that is required is going to be A3, which is under the line here, plus this bit, which is area 1. Okay, so the absolute value of it, area 1, which is that there. And then you want to negative out that. You want to take away A2. And A2 is going to be positive anyway, so that's all right. Okay, so that now is all of that area plus this with that taken out. So, okay, so that is it. Yep. So, okay, so A3, we have A3, which is 15. A1, how do we integrate that? Okay, so it's a third x cubed minus 2x minus 1 root 2, which is equal to a third, a bit messy, 2 by root 2 minus 2 root 2, okay, and then take away, left a huge amount of space for this, but a third plus 2. Let's be careful here. So it's minus 1 going in there, yeah. So, and we want to subtract all of that. Okay, so 2/3 root 2 minus 2 root 2 is what? So area 1 is equal to 2/3 root 2 minus 2/3 minus 6/3 root 2. Plus a third and minus 2, yeah? Is that correct? Okay, so it's minus 1 in here, so that'll be negative. Minus 1 in there, which means it's positive, and we're taking them away. Grand. Okay, just have to watch the signs. So that's equal to minus 4/3 root 2 minus that's 6/3, so minus 5/3. Okay, so it's A1. Okay, A2 is going to be something kind of similar because we're integrating the same thing, but with just different numbers. So it's equal to a third x cubed minus 2x, kind of the opposite numbers, just the other way around. Okay, which is equal to, okay, 8/3 minus 4, subtract 2 root 2/3 minus 2 root 2. Grand. So it's equal to bloody messy. 8 over 3 minus 4 plus 2 root 2 minus 2 root 2 root 3. Okay, well that's A2. Okay, so the answer then is going to be bloody messy with all those certs. Plus A required, so it's going to be 15 minus this guy, minus A1, or plus A1. Yeah, that is a negative number, as we can see, as predicted, because it's this negative area under the curve, but we're taking the absolute value of it. And then you take away A2. And that'll give the A required. All right. Positive constant, and work out the value of B. Okay. Bit of integration. That is 0. B, lots of B's. So B's everywhere. The B's, save the B's. Okay, equals E. So loads of B's. Okay, how does that? Well, that's going to be kind of nice because the B will cancel out there. So that will be E. So it's B over B. Yeah, okay, and that'll be just B0 equal to E. Okay, which is E to the power of B squared minus E to the power of 0 equals E. Yeah, okay, so E to the power of B squared, we have to find B, so isolate everything else, is equal to E minus 1. Log both sides, and you get B squared is equal to ln E minus 1. So B is equal to the square root of ln E minus 1. Okay, that's all right. Okay. Right. Okay, and that finishes section A. Right, so section B, you have to do 3 out of 4 here, so much more limited choice now than the old days. Question 7, I think, is going to be a really nice one for the applied maths lads and ladies who do applied maths, because this would be real applied maths question. A lot of kind of overlap there. So Fiona is driving on a motorway past point A. Her speed is given by VT. Yeah. Passing the point, T is between 0 and 5, and it's kilometers per hour. V is in kilometers an hour, but T is minutes after passing. So that's something you're really going to have to watch out. So kilometers an hour and minutes. So that's just something you immediately have to watch out for. Okay, work out Fiona's speed when she passes the point A. Well, at point A, T is 0. Point A, T is 0, so V of T is just going to be the end term there. 109 kilometers per hour. Okay, it does a pass a sanity check. It's a motorway, so a motorway can go up to 120k per hour, or I suppose if you're not too worried about penalty points, you might squeeze that a little bit. You know, who knows what you get away with these days, but okay, we can't condone speeding there. Anyway, so that's okay. So that's a fairly nice, easy introduction to it. Work out Fiona's acceleration, the rate at which her speed is increasing 5 minutes after she points part B. Okay, so T then is equal to 5 minutes. Yeah, so T is in minutes. Okay, what's her acceleration? Well, VT. So VT is equal to 2/3 T cubed minus 6T squared. It's 12T, so 109. So at acceleration then it's going to be just differentiate that fella. Okay, so it's 2T squared minus 12T plus 13, and that goes to 0. Okay, so that's the acceleration, and then at t is 5, acceleration is equal to 2 by 25 minus 12 by 5 plus 13. So acceleration is equal to 50 minus 60 plus 13. Acceleration is 3. So it's plus 3, yeah? Yeah. Okay, 3. Now, you have to be careful about its kilometers per hour per minute, which is a very unusual units for acceleration. Normally, acceleration is meters per second squared, but that's the ISO or the SI standard. So it's 3. Okay, anyway, it's 3. 3 with those units. Find the time value of t at which Fiona reaches her maximum speed. Okay, so we have acceleration here. So we're going to use that. So just building on the west. So it's when the acceleration goes to 0. So dv dt is 0. So that will give you our maximum speed. So 2t squared minus 12t plus 13 is 0. Can we factorize this fella? 2t, 1t, and it's probably say 13 and 1. Will that work? Okay, so both negative equals 0. Okay, let's say that would be minus 13t, and then nope, doesn't seem to go in nicely, does it? Minus 13t minus 12t minus 2t, so that doesn't seem to factorize. Have I made a mistake? Okay, let's go up here and let's see. Now, shouldn't necessarily be factorizable, but let's say minus 6t squared plus 13t. Okay, differentiating, that brings it to 2 squared minus 12t. Yeah, that seems to be okay. It's almost differentiable. So that is a little bit, maybe the other way is, would this work? T, nah, it's not gonna work. Find out the acceleration. Okay, when it reaches maximum speed in the first 4 minutes after she passes point B, point A, okay. Yeah, okay, look, it's not factorizable, but I shouldn't be assuming that it's going to be that easy. T is equal to minus b plus minus square root of b squared minus 4ac. A bit laborious having to use this messy equation. And you hope that it's going to factorize properly. Okay, so minus b, that's 12. Plus minus square root of b squared, 144. 4ac is this lad, which is 26 by 4, is it? Yeah, 26 by 4, which is what? It's 104, is it? Yeah, okay. Over 2a, which is 4. Okay, so it's 12 plus minus square root of 104, 40, square root of 40 over 4. Square root of 40, what's the, how much can we take out of that? 8 by 5, is it? Which, no use to us. 2 by 20. 4 by 10. Yeah, 4 by 10, I suppose. Is that going? Yeah, I suppose 4 by 10, yeah. plus or minus, so it'll be 2 root 10 over 4. Okay, now, so you're saying it's during the first 4 minutes after she passes, so it's t is less than 4, so it's presumably there'll be a -1 and a +1, or well there. Let's see, so t is equal to, let's say, 3 plus or minus the square root of half times square root of 10. Square root of 10 is what? About 3. Okay, so that's, so both of them will be positive. Okay. One of them will be more than 4. Yeah. So the positive version of this will be t is equal to 3 plus a half root 10. We can kind of forget about that because that'll be 3 halves. So it'll be about 4.5. So that actually is not applicable because it's not within the 4 minutes. You know, it's not within this 4 minutes. So it's discounted. So we only take the -1, which is root 10 over 2. So you're asked for 2 decimal places. So let's get the best estimate I can of this. So t is equal to 3 minus, okay, what'll that be? 3 and a bit, 3 and a fiddly bit over 2. I couldn't be bothered putting that into a calculator. So it's going to be, that's 1.5, yeah? So that's 1.5 minutes. It's going to be minutes. Can't make a mistake in that. 1.5 minutes. Okay. Grand. So that looked like it was going to be the factorizable, but it wasn't. Use integration. They even tell you to use integration to work out Fiona's average speed over the 5 minutes after she passes A. Okay. Average speed. Okay, so basically the way this works is the principle we're going to work on is this is t, and so this is the speed. So this is your average speed, and what we're saying is you're at an average speed, the area under both curves has to be the same. So the average speed is defined by where the area under the curve is the same. So in other words, the area under that curve is V average by t, and it's going to be, because it's t multiplied that, and then it's going to be the same as the integral from 0 to 5 minutes of v of t dt. All right, so that's what we're looking for. So, and we're looking for the average speed, so we'll just be taking that underneath here. All right, okay, so v of now is equal to the integral from 0 to 5 of what is v of t? Let's go back to it. Not that far. V of t is this fella. So 2/3 t cubed is 6t squared plus 13t plus 109. Okay, so integrate that lad there and see how we get on. Okay, so it'll be t to the power of 4. Rare we see that. So it'll be 2 over 12 minus, okay, t cubed, that, and then what's that? 13t, yeah. So which makes it what? Plus t squared plus 109t, and all of that is between 0 and 5, yeah? Okay, grand. So the 0 point will be easy because all of that will be 0. So we just have to work out the 5 point. So that's a 1/6, 5, well, let's say 25 squared, minus 2, what's that? 5 cubed is 125, plus 13 over 2, 25, plus 109 by 5. And the 0 bit is just 0, because all of those terms will just have t is equal to 0 in them. Grand. Now, okay, what else? So v average now is going to be 25 squared, so that's 125 by 5, yeah. Uh, 625. 625 over 6 minus 250 plus 13 over 2 by 25 plus 109 by 5 all over 5. Okay. That'll be the average speed. Okay, if you want his average speed, do it. Could I be bothered working that out? Oh my god. Right, so that's 1, 2, 5, is it? Yeah, because I'm bringing it back to that. Yeah, 125 over 6 minus 250. Minus 50 plus 13 over 2 by 5. Yeah, plus 109. Okay. God, nearly there. 20. No, yeah. Okay, 20. Now what's that? 5, 6. Jeez. Do you know, I'm just going to say that's about 21. Minus 50. Plus, what's that? 65 over 2, which is about 32.5. Plus 109. Okay. Yeah, so that's adding those fellas up. What's that? 59 plus this lad is 80, 91.5 plus 21 is equal to 111. The average then is equal to, and you have to be careful that it's kilometers per hour. That sounds reasonable. Okay, I've done a bit of simplification there because I don't have a calculator. I'm a complete Luddite, but I like to use my head, so there's probably an error there. But look, I think the general spirit of it is okay. Now, taking v dash to be the derivative and the second derivative. Oh, this is interesting. To be the derivative of that, to be the second derivative of that. Yeah, v dash of 1 is bigger than 1, and v double dash of 1 is less than 1. Okay. The graph must look like one of the photographs. I don't know. Don't really understand what they're coming from. Anyway, v dash. Okay, where's v dash and v double dash? We already have v dash, right? Where is that? It's up here. Okay, so v dash is 2t squared is equal to 2t squared minus, okay, where's the t? Minus 12t plus 13. V double dash is equal to 4t minus 12. Okay. Right. V dash 1. V dash 1 is equal to 2 minus 12 plus 13 is equal to 3, yeah? V double dash 1 is equal to minus 8, but it looks of it. Yeah? Yep. Okay. Yeah, so, yeah, that's bigger than 1, bigger than 0, that's less than 0, yeah? Okay, grand. So for the graphs shown below, close to where t is 1, the graph of y must look like one of the 4 graphs. y is equal to vt. Oh yeah, y equals vt must multiply photographs. Alright, okay, yeah. Okay, so answer. Okay, so answer A, B, C, or D. Okay, so which graph is y is equal to vt? Alright. So, okay. So what do we know about v dash of 1? V dash of 1 says that around t is 1, it's positive, which means the rate of change is, which means it's increasing. Okay, so v of t is increasing. So in other words, it can't be that. It could be this. It can't be that. And it could be this one. So in other words, it's either, according to v dash of 1, v dash of 1 says what's the rate of change of v, and we're saying that it is positive, so it is increasing, so it's increasing both of those, so it's B and D. So that would be, it would be B and D. All right, so for v dash of 1, it's B or D. For v double dash of 1, we're saying that's negative, which means the rate of change of the rate of change is negative, which means oh, that's a nice one. Using v dash negative, so the rate of change, I would say it's this one, because here, okay, yeah, it's here, it's increasing. So there, v dash, the rate of change is increasing, and the rate of change is increasing. But here, the rate of change is increasing, but the rate at which it's increasing is negative. Okay, so what it's showing here is that the velocity is increasing, but the acceleration is decreasing. So you can see the velocity is increasing up here, but the rate at which it's increasing is slowing down. So I would say the answer is B. It's a good question, and I'm not totally certain about it, but I think I'm going to bet on the house on B there, for the reason that in B the rate of change is positive, but the rate of change is negative. Okay, that is a nice question. I like that, and really get to think about it. An average speed zone, oh god, oh strike, that fear of me. There's only one of them, I think, is in Limerick, and it's a bit of a honeypot for penalty points. Average speed line on the motorway is starting at point A, ending at point B. Distance along the motorway is 10k. Yeah, and that is actually the one in Limerick. It's 10 kilometers long. Cameras record the time taken for each car's drive per my day, and then they get the average speed, and then they send you the bill for 200 quid in the post. Work out the minimum time that a driver getting made to be without driving above the speed limit. Well, the minimum time is if you go at the speed limit the whole time. So speed limit is 400 kilometers an hour. S is 10 kilometers. So velocity is equal to distance over time. So time is equal to distance over speed. So it's 10 over 100 that. So t is equal to a tenth of an hour, which is equal to 6 minutes. Okay. Rowan drives from A to B. Passes point A. Oh, this is real applied mathsy stuff. This is great. Plus point A at a constant speed, 120. So it's constant speed. So, okay, so he's at a constant velocity time graph, I suppose. 2 minutes driving that speed, so he's doing it 120. 2 minutes, starts to decelerate until he reaches point B. Okay. Alright. Okay, so this is point B, so that's point A, that's point B. This is time. Workout runs deceleration. Alright. Okay, so constant speed. Is he breaking the speed limit? Average speed one. The minimum time driving above 100 kilometers an hour. It seems to apply that that's the speed limit, and then this lad is breaking it, which is disgraceful. Okay, maybe we were saying he's getting away with it. Okay, he's driving at his constant speed. After 2 minutes, it starts to decelerate. He reaches point B. Okay, anyway, the principle is the area under the curve is the distance, which is 10 kilometers. All right, so we know that's 2 minutes. So the area then is going to be equal to 120 by 2 minutes. And then it's going to be equal to whatever this new fella is. Oh yeah, overall his average speed is 100. Okay. So if his average speed, so V average by his time will be equal to the distance. So the time he takes is equal to the distance over V-av. The distance we know is 10 kilometers. His average speed is 100 kilometers an hour. Oh yeah, of course he's evading it's the average speed problem. Yeah, exactly. So T is equal to 6 minutes in total. Okay, grand. So we know it's 6 minutes, so this extra bit is 4 minutes. All right. So what do we need to find? The deceleration. Okay, deceleration will be, the acceleration will be equal to the speed at the end, or the speed at the start, which is 120, minus his final speed, we'll call it V. Okay, last part of question 7, before I was rudely interrupted by this crappy iPhone, which has no memory left, and I keep running out. So get Brown's deceleration part G. So this is the speed time curve, and we know that the deceleration is the initial speed, which was 120, minus the final speed over the time it's taken, which we have figured out was 4. We know the total distance is going to be the area under that curve, which is that rectangle first, which is 120 by 2 minutes, and we'll have to convert into hours, of course, which is, so that's 1/30th of an hour, plus this little bit here, so it's V times the new speed times that time, which is 1/15th of an hour. And then by this triangular bit, which is half the base, which is 1/15th of an hour, by the height. So it's the 120 minus V. So that's the height of that triangle. And we know that total distance is 10. So just have to be careful there that you have to put it into fractions of an hour. So then work that out, multiply by 30, and you get this, and you get V. So the speed that it comes down to is 60. The acceleration then, we can pop it in here, is 120 minus 60 over 5. So it's A is equal to minus 15 kilometers per hour per minute. You have to put in the minus to say it's deceleration. Although I suppose strictly speaking, you could say deceleration is equal to plus 15 because you're implicitly saying that it's a deceleration. But if you're calling it an acceleration, it has to be minus 15 with that fiddly kind of units as well. units, factors. Okay, so numbers, positive prime numbers. Okay, so this is kind of stuff you do in college, actually, in first year. It's interesting, number theory and all this kind of stuff. 5 different factors of 2 to the power of 4. Well, it's kind of given implicitly in that. It's 2 to the power of 0, which is 1. It's 1, 2, 4, 8, and 16. So it's 2 to the power of 0, 1, 2, 3, and 4. So you have basically all of these powers, and you have more than the power, so you have one more than the power, which gives you 5. How many different factors 3 to the power 7 has? Well, it's going to be 3 to the power 7, it's going to have 8 factors. Because you know that every power of 3 is going to divide into that. So the 8 factor is going to be 3 to the power, so 1 is always it, and always the number itself. 3 to the power 7 is going to be 1 as well. And then all the other ones between it. 3 to the power 1, 3 to the power 2, 3 to the power 3, 4, 5, 6, 7. So it's going to have 8 factors. Work how many factors this has. Well, it's 2 to the power of 10 and 3 to the power of 2 to the power of 10 and 3 to the power of 17, is that? Or 12? Yeah, well, it's going to have this guy. It's going to have 11 factors, and this guy is going to have 13. So I would say it's 24 factors. All right, that's okay so far. She makes a table, she makes a little table. She makes a little table, okay. X, Y. So this is part B. So this is okay, we're doing all right so far. Keep our lit. Okay, 4, 6, what is it? 12. Okay, 12. So write out all the factors of 12 there. And then what you have to multiply them each to get 12. So that has to be that. 6, 2 by 6 gets 12. 4, 3, 2, and 1. Yeah. So it kind of goes up a D and down a D. Okay, plot the points. Plot the points, and you have 1 point there, 4 and 3. So it's going to be a kind of a, where this is 12 up here, 12 and 1. And this down here will be somewhere, it will be 12 and 1. So it'll be a 1 over x kind of shape. Because the x and y are multiplied by each other, and realizes that the relationship in x and y is equal to 12 over x. Draw the graph of y is equal to 12 on the coordinate diagram. Yeah, okay, we've done that already, haven't we? Yeah, actually, what they asked for first was plot the 6 points. Okay, so and then we draw the curve. So plot the 6 points would have been this lad here. So something like this. Yeah, just plot the 6 points, and then drawing the curve is drawing the 1 over x shape. So a 1 over x shape is like this, where it kind of goes to infinity in both directions. So it tends towards 0 as the other approaches. As one variable approaches 0, the other approaches infinity. So it's more correctly, it's kind of like this. Yeah, so that's the graph y equals 1 over x. Okay, so yeah, that's grand. A tangent to the curve is drawn at the point. Okay, P is this. Surely the equation of the tangent is this lad. Okay, so now we're in tangent. Okay, so a tangent to that curve. So that curve is equal to y is equal to 12 over x. And a tangent of the curve is drawn at the point P. Okay, so if it's there, then the tangent is going to be what is it? Right, yeah, it'll be the slope of the line will be the same as the differential, the slope of that fella at that point. Okay, so dy dx, yeah. So y is equal to 12 over x. Yeah, okay. Let's get the old fellas here, the old helper, the log snacks. And we need to find, okay, so we need to find the differential of 1 over x. I think it's ln x, isn't it? Isn't it, lads? Calculus, page 14. Okay, so differentiating, where's 1 over x? Oh, it's the other way, yeah, so ln of x differentiates that. So what about 1 over x? Yeah, x to the power minus 1, I suppose, yeah. Interesting. Yeah, because, okay, so it's y is equal to 12 by x to the power minus 1. Yeah, so dy dx is equal to 12 by minus 1 x to the power of minus 2. Okay, so the slope, okay, what am I doing? Yeah, the slope is equal to minus 12 over x squared, yeah, at that point. Well, at all points on the curve, but here the slope of the line is going to be a little bit. Now is, okay, we have to find out where the point is. So it's p 12 over p. So p 12 over p. So the equation of the tangent is, okay, so the equation of the tangent could be, say, y is equal to mx plus c, yeah? Yeah, so we need to find the y-intercept and 1 point. That's probably, yeah. Anyway, we do know what the slope of the line is. Okay, so at the point, okay, so so x is equal to p, yeah? Yeah, x. So x is equal to p, which means the slope is equal to minus 12 over p squared. Okay, so the slope of the line is that, and we have 1 point. So it's y minus y1 is equal to isn't it? It's x minus x1, isn't that the lad that you use? Yeah. Sure, it'll work out. So y minus 12 over p is equal to minus 12 over p squared to x minus p. Okay, so all that matters is just clean that up, and it's starting to look like this lad already. So I think we're on the right track. Hold your nerve, Kino. And let's go through. Okay. Just get it in the form of the yoki. Yoki. Okay, so y is, get it in the form y is equal to mx plus p. Okay, so it's 12 over p minus 12x over p squared plus 12 over p. Okay, yeah. So y is equal to minus 12 over p squared x plus 24 over p, which is QED, quad est demonstrandum. Grand. Okay, so I sorted that fella. That's good. Any other fiddly bits after that? There is a fiddly bit. Area of the triangle formed by the x-axis, y-axis, and the tangent. Okay, it continues. Okay. So so this fiddly fella, this fiddly tangent. Okay, so what do we know about this lad? Well, we know the equation of the line. Do we? Yeah. So we have the equation of the line, so we know quite a lot about it. We know a lot about you, lad. P squared x plus 24 over p. We know the slope of the line, all that kind of crap. Yeah. Okay. So the area of the triangle and the tangent is always k square units. Work out the value of k. Okay. Alright. So the area of that stuff. Okay, well, how would you know the area? Well, it would be half the base by the perpendicular height. By the height. Does that help you in any way? Probably doesn't. Well, we have y equals fx plus p plus c, sorry, which gives us the y-intercept. So it would give us that anyway. And actually, I mean, just skip over. Okay, so let's say x equals 0. So we'll find this intercept there, x equals 0. So y is going to be equal to minus 12 over p squared, 0, and 24 over p. Okay, so the y-intercept is 24 over p. What's the x-intercept? Well, it's when y is 0. So minus 12 over p squared x plus 24 over p is 0. X is equal to 24 over p. What do we do with this file? We multiply by p squared over 12. Is that it? Yep. Okay, so x is equal to 2p. Okay, that's nice. Okay, this is starting to work out, I think. So it's always a constant. That's interesting. Yeah. Anyway, so now we can get the half the base. So half the base is p by the perpendicular height. 24 over p. Oh, that's lovely. Oh, nice one. Is 24. So it's a cool 24. Okay, that's interesting that that works out so nicely. And that is it. That is it for question 9. That's quite a good question, question 9. It's kind of interesting. Yeah, I'd say that would have been a good one to do. Okay, question 10 is in a sequence in this series, fella. So triangle T1, height of 8, base of 2. 8, base of 2. So that's going to split that into 1, 1. And then each time you try and squeeze more rectangles into the triangle. So draw T4 in the grid below based on the triangle given on the grid. Okay, well look, T4, so it's going to have, okay, 1, 2, 3, 4, so about, yeah, so it's going to have 8 notches there, and the first 2, it's going to be a triangle, and the next 2, so it's going to be split in 4, each is going to have a height of 2. And you just create a triangle from each of these. So it's that, 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 and that. Okay, so the total area of the 3 rectangles in T3 is 32 over 3. Okay, so let's have a look at it. So it's gonna total area. Okay, so that's going to be 8. It's going to be 1 and 1. So that perpendicular fella splits that in 2. So it's base of 2. So it's split into 1, 1. Okay, so let's see. It has that. It has that. Okay, so that is going to be, well, the hypotenuse will be the square of both sides. So it'll be root 65, which isn't going to be much use to us, but that's just a fact. Okay, so let's do similar triangles. So the whole hat is 8, 1. So then you take a small triangle up here. Those two triangles are going to be absolutely similar. So that side is going to be similar with this. That side is going to be similar with that fella. And that side is going to be similar with the same one. So the ratio at which they're split is going to determine the ratio of the sides. Okay, so this fellow up here, that height is, we're told, is going to be 8 over 3 because they all have to have equal heights. Which means this side is going to be 1 over 3 because it's going to be in the same ratio. That is 1, that's going to be a third of it. Okay? And similarly for this guy, this is going to be a height of now 8 over 3 twice, so it's going to be 2/3 of 8, so that's going to be 2/3. Okay, so let's put in the rectangles. And so the area of the rectangles is going to be, right, well, the first fella, its height is going to be 8 over 3. They're all going to have a height of 8 over 3. So the rectangular height is going to be, the height is going to be the same for all these rectangles because we're told that's by definition 8 over 3. Then, so we need the base. So what's the base going to be? Well, it's going to be the base of the triangle multiplied by 2. So here we see it's going to be 1, so it's multiplied by 2. So all of them are going to be multiplied by 2, so let's keep the 2 out here. So just inside here now will just be the base, so that's 1. The base of this fella is 2/3, and the base of the last fella is 1/3. So 2 by 8 over 3. So basically putting it a bit more, so simply 1/3, 2/3, and 3/3. Alright, so that is 3/3, so that's 2. So it's 2 by 2 by 8 over 3, which is equal to 32 over 3, which is, what are we told? Yeah, QED. That's what we're asked to do. Okay, find the total area of the rectangle at TN. So I'll give you a little bit of there. Okay, so the area of the rectangle, so let's say it's N now. The area of the rectangles is going to be the height of each triangle, which is 8 over N this time. All of the triangles will have height then. What's the base going to be? Well, you're going to start with, again, it's going to be twice by the base of each triangle. So it's going to be 1 plus 1 over N, 2 over N, 3 over N, and so on. So 1 over N plus 2 over N, it's going to be the same as this. So it's going to be, where N is 3 here is 1 over N, 2 over N, 3 over N. So it's 2 over N plus 3 over N, and on until the end. Okay, so we now just have to work about this. Square units in terms of N in simplest form. Okay, so how do we work out that sequence? Well, Sn is equal to J's for start tables. How do you get Sn again? Sequence, where's sequences and series here? sequence in series 13. Okay. Where did that go? Oh yeah, here we are. So there it is. So that's going to be and it is an arithmetic series, is it? Or is it? No, it's not. It's a geometric series because it's multiplied by 1 over n each time, is it? You know. Let's think about it. It's 1 over n plus 2 over n plus 3 over n all the way to n over n. So that's 1 over n, and each time you're multiplying that term by an r. Okay, so the sum of the sequence is going to be a 1 minus r over n over 1 minus r. Okay, so what's r? It's an arithmetic series, isn't it? It's an arithmetic series where the additional is 1 over n, isn't it? Yeah. And I just have to think about this. Okay, so it's 1 over n. Yeah, so what you're adding each time. Okay, so your first term is this, and you're adding 1 over n to it. So a is equal to 1 over n, and d is equal to 1 over n. So an arithmetic series, so t of n then will be equal to 1 over n plus n minus 1 . Yep, okay, so yeah, that's the term. Okay, so s of n is equal to n over 2 into 2a plus n minus 1d. So n over 2 into 2 over n minus 1 d is 1 over n. Okay, so n is equal to n over 2 into n plus 1 over n. So s of n is equal to s n plus 1 over 2. Is that right? I'm messing it up with I think I'm mixing it up with different things. N minus 1 over 2, can that be right? Okay, let's take a value of n. Okay, so let's take n equals 3. So it's a third plus 2/3 plus 3/3. What's happening each time? You're taking this as that, and then you're taking a third being so that's a, and r is equal to a third as well. You sum them up and you get 2. Would that work? Yeah, that would actually work, yeah. Okay, that's a surprising result, but it would work. Okay, and then the squared, so the area is equal to 16 over n by n plus 1 over 2. So the area then is equal to 8 n plus 1 over n. Let's try that for area n equals 3. And you get a is equal to 24 over 3. No, it is equal to 4. It's 32 over 3, which is correct. Okay, so that's your area. Okay, that's your area for that guy. It's a little bit unusual. Okay. All right. Total area. Okay, so total area of a rectangle for the n term of the different sequence of group triangles is equal to this. So it's not the same as what I've got. Yeah, n plus 1 over n. Yeah, it's pretty much the same. Okay, so he's kind of giving the answer there. Kind of different. Total area a of n is equal to 8 into n minus 1 over n. Work out the value for n, the area of the triangle on the right. Okay, so the area of the triangle on the right is half the base by the perpendicular height. So the area of that triangle is 8. Yeah. And I suppose it's from, hang on now, that is 8 minus 1 over n. So the limit as an then brought to infinity is the limit of that. So that would go to 0, which is equal to 8. Yes, correct. Okay. So work out the value for n for which an is greater than 90% of the area. Okay, so what value? Okay, so that is bigger than 95% of 8. So bigger than what's 95% of 8? What's 5% of 8? It's 8 over 20. So 2 over 5, which is equal to 0.4. So it's 7.6, is it? Okay. So n minus 1 over n bigger than 7.6 over 8. N minus 1 bigger than, okay, n has to be positive, so it's no problem with going over there. 7.6 over 8. Okay, so basically we're dividing by 8 there, so that would be 0.95, nice one, by n. So it's 0.05 n bigger than 1 multiplied through by 20, is it? Bigger than 20. So the first value would be n equals 21. Yeah? Check it. And okay, to finish off question 10, you've had your area, now it's volume. Okay, so square base, pyramid, lengths, units. Okay, so fiddly diagram. So you have this little square inside in it. It's gone down with x, that's h. The area of the shaded square, so this square here, they're given that to you, is equal to sx, and it's x squared, okay, c over h squared. So it's basically like it's yeah, probably a better way of putting it is x over h squared c squared. So it's kind of like the the fraction that you're doing on x over h squared multiplied by c squared. Okay, is the area of that. So the volume of the pyramid is s of x dx. So find the integration, use integration, find that. H, so s of x is there. It's x squared, c squared over h squared dx, so just differentiate that fella. And you get x cubed over 3 between 0 and h, which is going to be h cubed over 3 c squared over h squared. That's it. That's it. That's all it is. Next fella, x starts to increase at a rate of 3 units per second. So the x dx dt is equal to 3. Find the rate of change of s of x. Okay. So s of x dt is equal to d s of x dx by dx dt. Okay, so that's chain rule. The chain rule. So we need d s of x dx, which is equal to, okay, so s of x is up here. So it's 2x c over h squared. Grand, so ds dt then is just going to be equal to that multiplied by dx dt, which is 3. So it's 6x c over h squared. Grand. Do I have to do anything else? Any other fiddly stuff? No other fiddly stuff. That is quite a good question. Question 10. Quite a nice one to end up with. And yeah, so that's pretty good. All right.